everyone, my name's Hannah and I work in the content team at Esri UK. Today, my box set is titled Maximise Your Transportation Efficiency. People don't stay in one place, so why should your data? Understanding how our populations and infrastructure move can help you make accurate decisions based on time and place. Esri UK offers a global location data portfolio so that ArcGIS users can add to their existing database with quality data variables from authoritative sources. Ready-to-use datasets include demographics, address data, environmental live feeds, infrastructure data, high-quality imagery, and frequently updated base maps. Today, I'm focusing on infrastructure and content for the transport sector. I'll be demonstrating ArcGIS StreetMap Premium and the TravelTime API. ArcGIS StreetMap Premium is a highly detailed road network dataset that is optimized for mapping, routing, and geocoding. It has worldwide coverage and also contains ready-to-use locators and points of interest data. StreetMap Premium is built using HERE data and processed into a routable network by Esri, ready to use in the ArcGIS system. StreetMap Premium comes with maps which are pre-symbolized at different scales to give consistent cartography throughout. You can still alter the styling, change the fonts, colors, and symbols, and you can also add your own operational layers. I'll use it today to solve the often complex location allocation question. TravelTime is a recent data partner to Esri UK and have made their multimodal transport data accessible to ArcGIS users via a new plugin. The API integration can be used to map location-based data by multimodal travel time, including public transport, instead of distance or as the crow flies. This data is also international and covers all of Europe, North America, Australia, plus a few other countries. I'll be demonstrating some travel time isochrones today to understand the journey times of my employees' work commute. Here we are in our desktop software ArcGIS Pro, where I'll just go over mobile map packages and how to add them for StreetMap Premium into your map. You can download entire continents of StreetMap Premium data in file geodatabase format. These are very comprehensive datasets, and all of the countries are linked in the network, but they can be quite hefty files as a result. A mobile map package consolidates maps into a single file and are available for StreetMap Premium on a per country basis. You can add the mobile map package from ArcGIS Online direct to ArcGIS Pro by going into Portal, ArcGIS Online, Groups, type in StreetMap Premium, go to the group of your choice, open it, and within here are all the countries included as individual mobile map packages. For the UK, I just right-clicked and then add and open. Before you download and use one of these mobile map packages, you must enable a StreetMap Premium extension. Your administrator can do this in the add-on licenses section of your ArcGIS Online organization. So once you have this, you can then use the mapping, geocoding, and routing functionality of StreetMap Premium. So this is what the data looks like. Each mobile map package includes the StreetMap Day base map, which is a vector tile package for mapping and visualization, as well as the routing network dataset available for the country you've chosen. The data on screen here is StreetMap Premium's 2021 first release, and so is based on HERE's 2020 Q4 vintage. This day map includes contributions from the GIS user community, giving it a really rich set of features, and as it's tile-based, has faster displaying speeds. You may recognise it as it looks like the navigation map available in ArcGIS Online and as one of the Esri base maps available in ArcGIS Pro. So that's what the data looks like. Now let's have a go at using it. Under the Map tab, I can use the Locate tool to perform single-line geocoding. When I start to type in here, this GBR is the StreetMap Premium Locator. The locators in the mobile map package include points of interest, so you can search for places such as coffee shop or train station, and a long list of locations is returned. I can also use the address inspector. here under Locate and select the StreetMap Premium Locator and then left click anywhere on the map and use it to find the address of any place that I click. On average, these locators are updated on a quarterly basis, so you know you're always using the freshest geocoding functionality available. The network dataset routing ND is present in the table of contents and ready to use for finding the fastest routes, closest facility, and generating service areas. It contains not only the location and attributes of roads, but also information about how the roads relate to one another, and information that affects what travel paths are possible and how long travel takes. Here I have a layer of 5 warehouses across the northeast of England and the addresses of over 100 staff members that need to get to these warehouses for work. Along the top ribbon here under Analysis, I can use the Network Analyst extension, which is linked up to my StreetMap Premium network dataset automatically. I'm going to use it to find out which of the warehouse facilities serve these staff members, and following this, which staff members may need support from me, the employer, in travelling to and from work each day. The location allocation solver determines the cost distance matrix of shortest paths between facilities and demand locations. This matrix is then used to find the best set of locations to which the demand will be allocated. I've already set up the location allocation layer in this project, and as you can see, it includes several sub-layers that hold the inputs and outputs of the analysis. I imported my warehouse layer as facilities, staff locations as demand points, and put the number of facilities up to 5. For problem type, I chose minimize weighted impedance, so it's the best option for the warehouse location problem. And this is the result. Just give it a second there. So there we go. There's our 5 warehouses and which staff members are best served to each one. The output geometry is in straight lines, but if we take a look at the attribute table of the facilities layer, we can see this demand count column here, and this lists the number of demand points assigned to each of the facilities. If I scroll through here, you can see some routing information, distance to the network, and total travel time as well. A really useful table of information there. So if, as a business owner, I'm looking to consolidate my operations and reduce the number of facilities while still ensuring that all of my staff have the best accessibility, I can change this facilities number down to 3 and rerun the location allocation analysis. So I'll just give this a couple of seconds to run. Great, and that's finished now. So you can see that the symbology for the South Shield site and the Middlesbrough location have changed from chosen to candidate. And the 3 locations left, if you see them in the attribute table, all have a greater number of demand counts for them because we've got more staff going to these locations. So using StreetMap Premium and Network Analyst, we've been able to determine the optimal warehouse locations that will service demand from my surrounding employee population. Adding public transport data to our analysis can offer additional insights when running an accessibility study. Without it, you can get incomplete results. So now let's take a look at TravelTime's multimodal transport data, available in ArcGIS Pro through their API plugin. You'll see from the demo that this API is really performant. You can throw thousands of points at it, or even batch process locations and calculate journey times and routes really quickly. Once I've downloaded and added the plugin using my unique API key, I can access it from this banner at the top and immediately run some simple analyses to create a quick route, time filter, or time map. Alternatively, I can access the full suite of analysis tools in the TravelTime toolbox from within the catalogue pane. The time map tool gives us the isochrones that we spoke about at the beginning. So let's take a look at Newcastle's city centre. Here we can create a visualization that illustrates the differences between driving and public transport catchment areas. I'll set my input location as city centre, time zone as Europe, London, and let's say I want to depart at this time tomorrow. From the drop-down, we can see a whole host of different travel modes and ones that are joined together as well. So there's not just driving and train, there's also driving plus train, driving plus ferry, cycling plus ferry. Maybe more useful for Amsterdam than Newcastle upon Tyne. I'll just put in public transport for now and give a 30-minute travel time. I'll click run on that. As you can see from this output, the areas in red show the locations that are reachable within a 30-minute journey by public transport, but not by car. In contrast, the blue areas show the locations that are reachable within a 30-minute journey by car, but not by public transport. As you can see, the isochrones returned are really granular. We even get these transport islands and also gaps in the analysis, which shows areas that are harder to get to. Carrying on from our work transport storyline, the next tool we'll look at is Time Filter. This tool creates origin-destination matrices and filters your input locations into reachable and unreachable areas. I'm going to set my staff locations as my departure locations, choose the unique ID, pop in the time zone, and I want them to arrive at work tomorrow at, let's say, 9 a.m. I'll set the travel mode as driving and pop in 60 minutes for travel time. My arrival locations will be the 3 warehouses we chose from the last analysis and give those a unique ID and click Run. From the results, you can see anywhere with a grey star is unreachable to my 3 warehouse locations within a 60-minute drive time. Anywhere in the green stars is reachable. So you can see a lot of my staff up near Berwick-upon-Tweed, at the Scottish border, around the Northumberland National Park, aren't able to get to one of my 3 locations within 60 minutes and arrive at 9 a.m. tomorrow. Now let's have a look and see how well my staff are serviced by public transport. So all I'm going to do is change the travel mode to public transport and give my output a different name, PT. Down here under Advanced, you can even add different penalties. So you can give less or more time for walking between bus stops, or the amount of time that you want to let your staff, say, wait at the bus stop or at the train station. I'm going to leave it as this for now and click Run again. As you can see here, we only have 1 staff member that is reachable to work at 9 a.m. tomorrow within a 60-minute journey time using public transport, despite these other staff locations being relatively closer to the warehouses. I can then use this information to inform decisions on where I'd like to expand or consolidate my warehouses, and helps give real-world context to this type of accessibility analysis. We have customers using this plugin in conjunction with local service providers to show evidence of gaps in the network and help to better facilitate their employees' work commute, whilst also keeping their company's environmental impact low and making use of public transport links. Here's an example of a potential output that can be created using layouts in ArcGIS Pro. We have a chart on the bottom left that gives a reachable within 60-minute journey count of our staff, a nice big map in the center that uses that travel time symbology to show staff that are reachable and unreachable to their work site. And also one of the tools for TravelTime that I didn't show today, the routing, and I've got down here a count of the routes that overlap for reachable staff, which again can be shown to service providers so they know where to expand their network. So hopefully that goes to show how we can use transport data to gain information on employee commutes, as well as reachable locations using multimodal transport. The examples here are just some ways in which you can begin to use TravelTime to enrich your location analysis. In summary, we have seen how an authoritative network dataset and multimodal transport data can enhance the Network Analyst tools already available in the ArcGIS system. We've used these datasets to understand how our people and infrastructure move, analysing location allocation and worker commuter times. Adding transport data to your location analysis gives you more opportunities to get new insights and enhance your decision making. If you're looking to get started or have a trial with any of the datasets shown here, please check out the resources at the end. Also, be sure to look at the ArcGIS Living Atlas, as well as Esri UK's full data portfolio, which covers all of the open and premium transport data we've not had time for today. Thanks for listening.